Next example. Which of the following list of numbers does form an AP? Which of the following list of numbers does form an AP? If they form an AP, write the next two terms. Write the next two terms. Here, four questions are to be given. So, here's the first list of numbers, second list of numbers, third list of numbers, fourth list of numbers. Okay, we can observe each and every list of number. Okay, these list of numbers are from an AP or not. We'll find that. Okay, if those are to be in AP, then we can find the next two more terms. Okay, if those are not in AP, then automatically no need to find the next two terms in the given list of numbers. Okay, so now the first question here, 4, 10, 16, 22. Okay, 4, 10, 16, 22 and so on. Okay, infinite number of terms are to be there. Here the first term a1 is equal to 4, second term a2 is equal to 10, third term a3 is equal to 16, fourth term a4 is equal to 22. Like that I read here. Okay, so then coming to that, differences of the consecutive. How can you say that the given list of numbers are in AP? Already I said in the previous example. Okay, the given list of numbers are in AP, then their common differences are to be equal. Common differences means A2 minus A1 result is also to be equal to A3 minus A2. That result is also to be equal to A4 minus A3. This we will observe that two values. Okay, A2 minus A1. Okay, 10 minus 4. The result is to be 6. Why? Because 10 minus 4, A2 minus A3, A1. In the same way, A3 minus A2, like that. A3 minus A2. 16 minus 10. 16 minus 10, 6. Both are to be equal. Okay, A3 minus A2, that is equal to A2 minus A1, that is equal to 6. Okay, then these results are equal to one another, each other. Okay, one another. So for example, in some cases A2 minus A1, A3 minus A2 are equal, but the result is not equal to the A4 minus A3. By seeing the example, we can say that if those are in AP or not. Why? Because the values are to be very small numbers, very small numbers. Okay, A3 minus A2 is equal to A2 minus A1. No need to do the next one, A4 minus A3. Why? Because 22 minus 16 is equal to 6 only. Then all those results are to be equal. Okay, then automatically according to that, so the given list of numbers form an AP. The given list of numbers form an AP. If those are not equal, then automatically the given list of numbers does not form an AP. Okay, here those are equal, so you can say that those are in AP. The question is, if they form an AP, then find the next two more terms. Find the next two more terms. How many terms are to be given here? 1, 2, 3, 4. Next two terms means fifth term, sixth term, you can find here. So, with the common difference, here the given list of numbers form an AP with the common difference D is equal to 6. With the common difference D is equal to 6. Okay, so already we know that first term and the common difference in the problem. Okay, so here next two terms. What are the next two terms here? Four terms are to be mentioned. Then automatically next term is to be A5. Next term is to be A6. So next two terms A5 is equal to A4 plus D. A4 plus D. How can you say that A5 is equal to A4 plus D? Already said, in an arithmetic progression, each and every term is adding by its each and every term is added with its common difference, then automatically we will get the next term. Okay, except the first term. Here common difference is added to the fourth term, then automatically we are getting the fifth term. Common difference is at the fifth term, then we are getting the sixth term. Common difference is adding the sixth term, we are getting the seventh term. Same way. Okay, yeah. A5 is equal to A4 plus D, that is equal to A4. A4 is equal to, in the problem is to be 22, plus common difference is 6 plus 6, 28. Then common difference is to be common. Okay, it is to be common in the total problem. Okay, A5 plus D. For the 28 we can add the 6, then automatically we are getting the next term 34, that is the sixth term. For 34 we can add the 6, we are getting the 40, that is the seventh term. For 40 we are adding the 6, we are getting the 46, that is the next eighth term. Okay, so that is the way we can solve the next two. We can find the next two more terms in the given arithmetic progression. If the list of numbers are in AP, then you can find the next two more terms. The list of numbers are not in AP, no need to find the next two more terms in the given list of numbers. Okay, so So this is the first problem completed. Coming to the second problem, 1 minus 1 minus 3 minus 5 and so on. Here the given list of numbers 1 minus 1 minus 3 minus 5 and so on. Okay, so first of all you can observe the thing, those common differences are equal, then automatically this is in AP, otherwise it is not in AP. A1, A2, A3, A4 are right here. A1 is equal to 1, A2 is equal to minus 1, A3 is equal to minus 3, A4 is equal to minus 5. Already wrote here. Okay, so then differences, A2 minus A1, minus 1, minus symbol as it is, then 1, minus 1 minus 1, minus 2, same way. A3 minus A2, A3 minus 3, minus symbol, A2 minus 1, minus 3, minus of minus 1 means plus 1, minus 3 plus 1 is equal to minus 2. Then coming to that, by observing these two, we can observe the A4 minus A3 simply. A4 minus A3, A4 is minus 5, A3 is minus 3. From that minus 5 we can subtract the minus 3, then automatically we are getting the result is also to be equal to minus 2 in the situation. Then automatically conjugative terms differences are to be equal in the situation. Then those are in AP. So then A3 minus A2 is equal to A2 minus A1 is equal to minus 2. Okay, so the given list of numbers form an AP. The given list of numbers form an AP with the common difference. What is the common difference in the situation? Minus 2. Minus 2. Okay. So, okay. If the common difference is minus 2, those are form in AP. Already in the question, if the common those are in AP, then automatically you can find the next two more terms. So already 4 terms are to be mentioned in the question. The next two terms are A5 and A6. Just now I said it. So for the fourth term we can add the common difference, we are getting the fifth term. For the fifth term we can add the common difference, we are getting the sixth term. For sixth term we are adding the common difference, we are getting the seventh term. So in that way A5 is equal to A4 plus D. In the problem A4 is equal to, what is the A4 here? Minus 5. D is equal to minus 2. Minus 5 plus of minus 2. Then minus 5 plus of minus 2. That is equal to minus 7. So for that minus 7 we can add the common difference minus 2. Then we are getting the result is minus 9. Then what are the next two terms? Minus 7 and minus 9. Therefore the next two terms are minus 7 and minus 9. Minus 7 and minus 9. Then coming to that, given list of numbers, the third question in the problem, minus 2, 2, minus 2, 2, minus 2 and so on. What is that? Minus 2, 2, minus 2, 2, minus 2 and so on. It is the first term, it is the second term, it is the third term, it is the fourth term, it is the fifth term. Okay, just you can observe the differences of the consecutive terms here. A1 is equal to minus 2, A2 is equal to 2, A3 is equal to minus 2. What about the A2 minus A1? A2 minus A1, 2 minus of minus 2. 2 plus 2. Why? Because minus into minus plus 2. 2 plus 2. That is equal to 4. Then coming to the differences of these two terms. A3 minus A2. Minus 2. Here plus 2. So then automatically minus 2. Minus 2 minus 2 is equal to minus 4. Okay. So because symbol here minus, the term is positive. Minus 2 minus 2 is minus 4. A2 minus A1 is equal to plus 4. A3 minus A2 is equal to minus 4. Those are equal? No, those are not to be equal. Then what do you write here? A3 minus A2 is not equal to A2 minus A1. A3 minus A2 is not equal to A2 minus A1. Here the differences are not equal. Then automatically there is no common difference in the problem. If there is no common difference of the list of numbers, then automatically the list of numbers does not form an AP. Okay. So therefore the given list of numbers does not form an AP. The given list of numbers does not form an AP. Okay, if those are not in AP, then automatically you can no need to find the next two more terms in the problem. Already in the question the word is to be mentioned. If those are in AP, find the next two terms. Here the list of numbers are not forming an AP, then automatically no need to find the next two terms. Okay, so now coming to the fourth example in that fourth question. Given the list of numbers 1, 1, 1, 2, 2, 2, 3, 3, 3 and so on. So infinite number of terms. The first term, second term, third term, fourth term, fifth term, sixth term. By seeing that we can say that simply. So here the difference is to be 1. Here the difference is 0. Here the difference is 0. But here the difference is 1. Here the difference 0. Here the difference 0. Here the difference 1. but the differences are to be changing in the situation. Okay, then automatically these numbers are also not forming AP. Okay, so by seeing that we can say that those are in AP or not. Okay, so we'll do the problem by the procedure. Here a1 is equal to 1, a2 is equal to 1, a3 is equal to 1, a4 is equal to 2. So a2 minus a1, 1 minus 1, 0. a3 minus a2, 1 minus 1, 0. Okay, so in the previous problem just we can solve the a2 minus a1, a3 minus a2 by observing that if those are equal, those are in AP. Those are not equal, those are not in AP, you wrote it in the previous problem. But here, by observing these two problems, these two differences, you can't say the thing. Why? Because by seeing that, you can say that. So, these are in AP or not. Then coming to that, by procedure, you can go to the next one. So, which one is not to be equal in that differences? A4 minus A3. What's the A4? 2 minus 1, 1. Okay, we can observe the thing. So a2 minus a1 is equal to 0, a3 minus a2 is equal to 0, but a4 minus a3 is not equal to 0. You got it here? 1. So those differences are not equal. So, okay, if the differences are, all the differences should be equal, then automatically those are in arithmetic progression. If those are not equal, then automatically the difference is not to be common in that question. Okay, so a2 minus a1 is equal to a3 minus a2 because those are equal, but the result is not equal to a4 minus a3. The result is not equal to a4 minus a3. Then automatically the given list of numbers are does not form AP. The given list of numbers does not form an AP. Then those are not in AP. Then automatically no need to find the next two more terms in the problem. Okay, students. So now we know that how can you say that the given list of numbers are in AP or not. If those are in AP, then we can find the next two more terms or three more terms or any number of terms. Okay, any number of terms. Okay.